Hey everybody, Jared here. I'm going to be doing my first assignment in this class on over-sedimentation and turbidity issues on the Mad River and how that can lead to some pretty extreme habitat issues. So a lot of you have driven by or tried to fish the Mad River and have seen that it doesn't take very much rainfall before it gets completely brown and blown out and turbid. And so my report's going to be explaining a little bit as to why um, that's more of an issue now than it has been in the past. So getting to know a little bit more about the watershed. Generally a pretty small to medium watershed for this part of the state. Pretty narrow, as you can see on this USGS map. It's very narrow, doesn't really have wide stretches until you get down toward Arcata. A lot of the majority of the watershed is heavily forested. The eastern portions are not so much, but most of it's very heavily forested, and large tracts of it now are owned by timber resource companies and private ownership, but also in the some parts of the central and eastern Trinity County part of the drainage are also Forest Service land. So there's some public land, but it's a lot of timberland. The basin receives about 40 to 80 inches of rainfall annually. Everybody knows rains like crazy up in here. The 80 inches is more toward the central part, middle portions of the Mad River drainage. The water yield is about 1 million acre feet a year. And to compare that to some other larger drainages in the area, the yield gets anywhere between 5 and 8 million acre feet a year, and the Klamath can get up to 20 million acre feet a year. So it's a medium watershed, but it has a lot of implications for the Humboldt Bay. And it's currently listed because of the turbidity and temperature issues that that we've been experiencing lately. I mean, almost every summer now, there's reports and advisories for harmful algal blooms and temperature issues. And in the summertime, you can get quite quite hot water temperatures approaching 20 Celsius or higher. So for salmon, that's really bleak. Now we're going to get into some of the causes of these excessive erosion events, both natural and anthropogenic. So the first thing you should probably understand about this situation in general is that part of it is just because of the geology and topography of the region. On this USGS map, you can see that we're in this blue range, which is called the Franciscan assemblage, and that's characterized by uplifted former seafloor that's very sedimentary, it's very sandy and gritty, and it can break apart and fragment into fine particles pretty easily. And a lot of the Mad River drainage is river canyons that make it really easy for landslides to happen. And then when we get these crazy, which are supposedly getting more increasingly uh, violent rainstorms that happen in our winters, it's able to pick up all that sediment and bring it way further downstream than it maybe could if we didn't have so much rain. The logging industry is a lot of what is being pointed at as the cause for the sedimentation issues and turbidity issues on the Mad. Really intense periods of logging in the late 1800s. In fact, there was even a railroad that was built along the canyon of the Mad River around Blue Lake and a little bit higher to bring it all the way down to Arcata to bring logs down from the higher country in order to be processed in the bay. So the railroad combined with the intense logging is a primary cause of the disturbances in upper drainage, which translates to all the issues and turbidity that we're having down in the lower drainage. Here's some pictures I got of eastern Humboldt County. So this was actually on the North Fork Mad around Berry Summit on the picture on the left, which is, you can see it's pretty well clear cut. The clear cutting seems to go right to the riverbed or at least a flat part of the drainage. So they're really going hard with the harvesting. And on the left, there's a picture of the Arcata or Mad River Canal that was created to float logs down. And you can see the sides of the canal are very channelized, very unnatural and straight. And yeah, you can see all this effort that was put into just basically mining on the Mad River drainage. high intensity logging continued to go on up until about the 60s, and that's when science and people started to realize the devastating effects of clear cutting and high intensity logging, and that triggered the pullbacks and the rollbacks on the logging industry in this region. In fact, that caused a pretty big economic decline and downturn when the logging industry started going under severe scrutiny in the 90s. Another major human disturbance on the Mad River is gravel extraction. Still going on quite a bit today. It's a pretty good industry on a land use industry on the Mad. Uh, there's about 4 or 5 companies that have gotten contracts to go onto the riverbed and extract gravel to be crushed and to use to make concrete. Another industry that was pretty prevalent and high intensity in the 40s and 50s after World War II in order to build concrete and build buildings and promote the infrastructural growth of the area. And still in 2025, there's still about 132,000 cubic yards of gravel and cobble that's removed from the lower Mad River floodplains and river bottoms. And there's actually been a few companies that during the reviews, they found went over their allocations. So it's still a pretty important and thriving human land use that could be affecting the Mad. Now we can get into some of the effects of these high turbidity events and how excessive sedimentation can really hamper habitat quality and water quality. So you can imagine these heavy landslides and high amounts of sedimentation from logging, leftover logging, that are trapped up in the upper drainage. When we get these massive rain events, it brings it down from the higher, uh, rougher topography, higher gradient upper part of the watershed down here to the lower watershed where it's able to settle out. And at the same time, we're also allowing gravel extraction in order and for an industry to come through and remove the gravel from the stream bed. So we're bringing fine sediments in, but at the same time, we're also bringing some of the large cobble out. And so because of that, because of these issues from the upper part of the drainage, we're starting to see the effects of high sedimentation and turbidity and concretion, the loss of pore space. So you can see that picture on the left is a well aerated, cool stream that has a lot of pore space and interaction between the groundwater. But the Mad River is slowly transforming into what you see like on the left, where all of that gets buried and covered by a flat layer of fine sediment. So all that pore space and exchange with the groundwater is lost. So we know also from class that when you lose that exchange with groundwater, and now because you've also lost a lot of depth as the stream bed fills up with sediment, the temperature is going to also rise. So this lack of pore space can be pretty detrimental to some of the aquatic organisms living in the creek. Um, like juvenile salmonids, they need that pore space in order to have a refuge from the flow, so they're not running marathons constantly trying to keep up. They also need it for visual cover, so they don't get snatched up by a bird or another fish. And they also use it for a hide and wait spot as they wait for the flow to bring them fresh food. They have something to hide behind. It's also really important for macroinvertebrates, which are a big part of the food chain. And so they need that cold water exchange as well, and also a physical structure to latch onto, to lay their eggs on, and to have a little cavity home within the creek. So another effect of the loss of that pore space is now that we have a warm, flat, silty environment, it's a perfect spot for harmful algal blooms. So they'll need uh, that fine sediment to put their roots down and their structural support. And now that the water temperatures are higher, they're just loving it. So these harmful algal blooms every year coming out more and more prevalent, which is a big concern for us people who drink from the Mad River each year. And so in the summer, when the temperature goes up, you really have to be thinking about the river conditions that are just upstream. And so now that the river has multiple listings and these problems are starting to be seen more and more as a future problem and something that we can forecast and anticipate on, there is definitely some management and mitigation that's been happening to manage the turbidity on the Mad. So first there was the TDML that was created by the North Coast Regional Water Quality Board, which is basically a upper threshold limit on how much turbidity can be allowed in the river due to man-made causes. So obviously you can't really do anything about just a heavy rain event, but any kind of activity that could cause turbidity anywhere in the drainage, whether it be gravel mining or timber harvest, it has to be accounted for in this total daily maximum load. So if that activity is causing a heavy increase in turbidity, then it's going to be checked out by that water quality board. So I think a really important aspect of going forward and what we can do is destroying and decommissioning a lot of the logging roads. So those logging roads are just hot messes of turbidity in the rainy season, where that compacted dirt just gets transported and becomes a mud river right down to the drainage. So I've walked along some of these decommissioned roads in the timber regions, and they're really effective. They're effective at so what they do is they basically fell trees and brush and dirt on the old logging road. Essentially, they destroy the road and make it try to make it as close to a natural hillside as it was, and so that will really reduce the erosion that gets brought down to the river. Another silvicultural or logging practice that's pretty widely implemented all up and down the West Coast now is riparian buffers. So people notice that if you leave the trees along the riverbank intact and leave that riparian corridor unharvested, that really significantly reduces the amount of sediment that gets brought down into the main stems. So I think that increasing the riparian buffer um, as far as tree harvest and as far as road development would be a really critical area that we can make better strides in that could potentially help out the drainage. Another restoration effort that's being undertaken by the Blue Lake Rancheria tribe is that they are going through the main channel as well as tributaries, and they're scouring out and trying to make a deeper V into the channel so that the water velocity is increased and stays in one area, and that will hopefully flush out the sediment better. And they're also coming up next year. They've got a pretty big grant to do a lot of heavy planting with native vegetation. So that will try to, the roots of willows and some native riparian trees are really great at holding the bank together and stabilizing those large cobbles. So if the trees can become established really well, they can really hold that cobble in place and allow the sediments to be flushed out. So lastly, I think one of the most important things that we can do as somebody who loves to go out and get data in the field, I think one of the most important things going forward will be to just monitor the situation. And with Secchi readings, you've seen how easy it is to go out and take a Secchi reading, how quick it can be, as well as going out with handheld units to see how the turbidity is changing throughout the year, as well as how the turbidity is changing in response to the different restoration events that are happening. Well, I hope that you were able to learn a lot about a local watershed and some of the issues that are happening just upstream of us here in Arcata. Here are some of my references, and thanks for watching.